Welcome to the Living Lab lecture series. I'm Victor, and within ScaDS.AI I work in the Data Privacy and Security group. There I mostly concern myself with cybersecurity problems in the smart home. In today's topic I want to present how we use large language models to create security notifications that enable smart home user, regardless of technical background, to take care of the cybersecurity problems inside of their own home network. But first let's take a step back and have a look at what is a smart home and why are there so many cybersecurity problems in the smart home. I asked AI to generate a stereotypical image of a smart home. In ads, smart homes are often shown just like this. The smart heating and AC system keep the temperature perfectly balanced in here, no matter the season. If it's still dark in the morning, the smart light bulbs gently turn on to wake you up. No blinding lights, just soft glow easing you into the day. Then, as the evening rolls in, the curtains glide shut automatically, thanks to a smart motorized system that responds to the time or even just the setting of the sun. And even the garage door is smart. It opens with a simple voice command or a tap on your phone. Let's take a closer look at one of those devices. For example, the smart light bulb. Now, what makes this lamp actually smart? Inside here, there's a tiny computer and a Wi-Fi antenna, but that's already enough. With this, I can connect the light bulb to my home network and control it from all over the world. I can turn it on, I can turn it off. I could even change the color and brightness, all completely remotely. What's really surprising is how cheap these things are. Despite the fact that they're basically a tiny computer, you can buy smart bulbs for as little as €5. Other smart devices are also not that much more expensive. But this is where it gets interesting and a little concerning. To be that small and that cheap, these devices don't have a lot of room or budget for strong security features. That makes them easy targets for hackers, and that happens frequently that smart devices, just like smart bulbs, get hacked. Hackers then don't actually just want one light bulb. Their real goal is to take control of thousands or even hundreds of thousands smart devices all at once. What they want to do is to build an army of smart household devices. So what happens when an attacker gains control over thousands of smart devices like light bulbs, thermostats, or even garage doors? They form what's called a botnet. Basically, a digital army of all the hacked devices. And with this botnet, attackers can launch a very simple yet incredibly powerful type of attack. Here's how it works. The attacker sends a command to all the devices in the network, telling them to flood a specific website with data, as much and as fast as possible. The result is that the server behind the website gets overwhelmed by the sudden traffic spike, the data traffic spike. It can't handle the sheer number of requests and either slows down massively or even crashes entirely. During this, regular users trying to access the site are completely out of luck. This kind of attack is called a distributed denial of service, or DDoS for short, and it's not just used by random hackers. It's even a tactic in modern cyber warfare used to disrupt communication and services of opponents. These attackers often start with a single smart home getting hacked, and the owners are completely unaware that their smart devices may be part of such an attack. At ScaDS.AI, we wanted to take a closer look at how we could detect when a smart device, like the lamp I showed, gets hacked. To do this, we set up our own experimental smart home. We bought a whole bunch of smart devices that you can see here and connected them all to a shared test network, so to say our own experimental smart home. Now, one big challenge when working with smart devices is that you can't really look inside them. You can't just install an antivirus program or connect them to a monitor to see if all the programs are running regularly. They're basically black boxes for the regular user. But What we can do is observe the network traffic, the data the lamp receives and the data the lamp sends. And when you do that, normally smart devices like this lamp barely talk at all. The traffic is in fact so minimal that you sometimes even can see if a lamp gets turned on or turned off. But when a device like this is part of a DDoS network, this changes drastically. Suddenly there is a lot of communication, and this is exactly the kind of anomaly we want to see to detect a cyber attack. This is essentially how intrusion detection systems work. It monitors behavior and flags anything that looks suspicious. If you want a deeper dive into how intrusion detection systems work, check out lecture number 17 in this series by Jörn Hoffmann and Martin Grimme. They go into great detail on the technical side of things. But there's one catch with IDS. They're designed for cybersecurity or IT experts and not for the average smart home user. Let's just take a look at a typical alert message from the Snort intrusion detection system. It says malware CNC HackerKit botnet traffic. If you're not a professional, that might as well be gibberish. To make intrusion detection alerts like this one understandable, we started experimenting with large language models. Our goal is to translate IDS alerts into usable and actionable security notifications. And these security notifications shouldn't be generic. They need to match the user's technical background knowledge, the actual attack that's happening, and the specific device that's being targeted. To try this out, we built a simple prototype. Here you can see that we structured our security notifications into 3 parts. First, in yellow, a simple explanation of what is happening to which device right now, what sort of attack is going on. Next, we outline the potential consequences if the user does not take action. For example, that the attack could spread inside their network, or that one of the devices might already be part of a botnet, attacking other smart homes or websites. Finally, we provide the step-by-step guideline the user can follow to stop the ongoing cyber attack and secure the smart home again. Using a large language model inside a smart home to create cybersecurity notifications for non-expert users opens new possibilities, but it also creates a lot of questions. That's why I want to demonstrate our current research on how we want to research this approach from 3 different perspectives. First, we talked with ethicists and distilled some guidelines to see what responsibilities we have when AI is involved in cybersecurity communication with layperson. Next, I'll present the psychological user study we conducted to explore how length and complexity affects those security notifications and how people understand and respond to those variations. Finally, I'll show you our evaluation framework that we developed to measure the quality of our notifications so that we can keep on improving them. Together with Hermann Diebel-Fischer and Birte Plato, who both also work at ScaDS.AI, we discussed the ethical dimension of using LLMs for cybersecurity advice inside of a smart home. But it's important to note that these insights we're gaining here don't just apply to smart home notifications. They could be applied to any system that uses LLMs to support non-expert users in cybersecurity tasks, especially when trying to communicate with cybersecurity expert systems. Now, the first guideline we discussed are thresholds. From a security standpoint, it might always seem like a good idea to be on the side of caution. It's better to take unnecessary action than to fall victim to a cyber attack. But if security alerts for user become too frequent and too disruptive, users might simply start to ignore them, which needs to be avoided. And this is why the user needs to be involved in setting a threshold. We all have our own risk perception, and with that knowledge, we want to define a sensible default setting which users can then customize to fit their own preferences. We're asking further questions as well. Please remember that we don't have the answers yet, but these are more the guidelines that we want to follow when implementing the system. We talked about how if different device categories, let's compare a smart fridge or a smart security camera, if those need different risk thresholds, if we need to define device categories for when a notification is triggered. Since a compromised camera or microphone might carry a different kind of risk than a fridge that's just being used to send spam to other people. Also, the design of notifications. Should the system increase severity over the message when messaging over time, when informing about the same attack? This could be helpful, but it could also backfire again if the user now becomes desensitized to the notifications and then only follows the really serious alert notifications that have been going on for days. These are some of the ethical guidelines we follow. Next, we want to go over to the psychological dimension. For our user study, we worked together with Charlotte Löffler from the Department of Cognitive Psychology at the University of Kassel. We have conducted a user study with 130 participants on Prolific to explore the influence of the length of security notifications and the complexity of security notifications. That is, the complexity of the language. How many technical vocabulary can we use? The motivation of the study is fairly simple. We want to find out a general direction in which we have to move to design our security notifications. For the study, we defined a total of 6 different categories. One dimension for those categories is the length. Here we defined short and long notifications, and for the complexity we have chosen beginner, intermediate and expert. A beginner user for us is someone who can perform basic tasks like turning a device on and off, seek help or follow simple instructions. Now an intermediate user is a little more advanced. They are familiar with the smart home setup basically and can manage tasks like device or router resets. They can install updates, check the firmware or change passwords. Now an expert user is basically an IT expert already who only needs some assistance with cybersecurity specific issues. Here is one example notification from our study. This is a long notification with 4 steps. Short notifications only have 2 steps. This notification is meant for the intermediate user types, and we have created notifications just like this one for all 6 categories. Now here you see the example web page of our online user study that we conducted on Prolific with the 130 participants, and this is what each participant saw. Exactly 30 times. We provided a stratified random samplings of 30 security notifications and let each of the participants rate those security notifications on a 7-point Likert scale for likability, understandability, trust and motivation. You can see the evaluation of the motivation variable. I want to use the motivation as an example to not get into much detail since the other variables also led to very similar findings. Our results show that users, and this is completely regardless of their technical proficiency, they all responded most positively to notifications for the intermediate user level. And this was consistent across all variables that we tested. Now, when we look at the length, it varies more. Beginner prefer longer messages. Those were the notifications with 4 steps. And experts, they slightly prefer shorter messages. Those were the notifications with only 2 steps. Now, with these ethical and psychological guidelines and findings in our mind, we want to tackle another problem when working with LLMs. And this is that we need some sort of quality assurance when we let large language models generate those notifications, since they could hallucinate and just produce nonsense or factually incorrect notifications. To do this, we created an evaluation framework with 7 dimensions. Here you can see the 7 dimensions we use to evaluate the security notifications. On the top you see consequences. This refers to if the consequences of an attack are translated correctly into the security notification. Then if the urgency of the matter is translated correctly, if the security notification is personalized and tailored to the user, if the guide to resolve the problem is intuitive, if the message itself is correct or not, if the countermeasures presented are correct, and last, if the context of the message is correct. So if the ongoing attack and what is happening around is described correctly. Then in this spiderweb diagram, you see that we compared one prompt on several different large language models to see for our use case which model fits best. This is one of the experiments we conducted and one of the use cases you could use this framework for. Another experiment we conducted was to run 2 different prompts, but now on the same LLM, to see which prompting approach works better, to do some prompt engineering and see how we can improve our security notifications. Now, in these preliminary experiments, we found that our framework succeeds in differentiating low and high quality security notifications, but of course only manually in an experimental setting. What we want to do now is to improve our framework that it can further assess the guidelines from ethics and psychology we defined, and of course we want to automate it using an LLM as a judge approach. Now we're already at the end of the video. I wanted to motivate why we need an interface to our home network, especially when we have smart devices included. When we have a smart home, so to say. Every user should have the option to be aware of ongoing attacks on their devices. And we want to realize this by creating an interface with security notifications to the network. This we want to do by integrating not only cybersecurity expert systems, but also the LLMs that create the security notifications. Please remember that in this talk we used intrusion detection systems as an example, but we could also do this with vulnerability scanners or firewalls. In this talk I briefly showed how we use LLMs to generate those security notifications, and I gave an overview of the ethical guidelines we could define, a user study we conducted, and finally the evaluation framework we created to assess the quality of the security notifications. Now, thank you very much for your attention, and if you have any questions, please don't hesitate to write me. I'll gladly answer them.